For my research area here at City is in photonics. And as you may be aware, photonics is a multi-billion-pound industry globally. So everything that we do, every product that we use or technology that we access has photonics in it to some extent. So whether you wear glasses, which is one kind of optics, or you use a laser printer, which is another kind of optics inside it, or you have laser surgery done, which is a third kind of optics, or you go to a supermarket and scan something, that's another kind of optics. Optics and photonics are part of our lives, and that's what I work on, and that's why it's such an exciting thing to be part of. Specifically, I work on numerical modeling of photonic components, which means that I use some mathematics to model components and what's happening inside them on a computer. What it does is it saves a lot of time and it saves a lot of money for people. Because as you can imagine, if you were to make a long fiber, as in a telecoms fiber, it takes a lot of time to get it right. So you'd design it, then you'd fabricate it, spending a lot of money, then you'd test it and you'd find something is not quite right. Then you'd go back to designing, testing, fabricating, redesigning, and so on. And that takes a lot of time and money. But if you could do it on a computer fairly quickly, you save time and you save a lot of money. You can also try out things that are not possible right now with the current technology. So for example, the field of metamaterials is all about that. Well, the primary motivation for writing this book is that I wish I had a book like this when I started working on finite element method. Now, FEM or finite element method was primarily used by civil engineers way back in the 60s, and then mechanical engineers and electrical engineers as well. So there are several excellent texts. But in civil engineering, the engineers are concerned about properties of solids. They want to know about the stress and strain. They want to know about the elasticity and Young's modulus. But in photonics, that's not what we're concerned about. We want to know how the electric field and the magnetic field will change if the refractive index changes. What about the continuity of field? So we're talking about completely different physics in a sense. And to translate the concepts of finite element from civil engineering texts to photonics was quite a challenge. And I wish I had something which was easier and was specifically aimed at people in photonics. So that's why I thought it would be nice to have a text that sort of explains those aspects. The key features of the book for me are the fact that it brings together all the developments of finite element in one place for the photonics community. So the FEM includes modal solutions, it includes BPM, it includes time domain and physical effects. All of these come together in one place. So even though the method has developed over decades, the reader can look at this one book and get all the developments that are necessary for modeling at this point of time and do modeling at its most advanced stage. Secondly, the book is very rigorous. So it gives you all the details about the method in exactly the kind of accuracy that a user would need. However, the book is also accessible. So we've tried to create something that's easy to read, easy to understand, and yet be very, very rigorous. Finally, there's a website that accompanies the book, and on this website, we've put together all the code that we have used to model different devices. This code is available to the user to download, so they can use it to model their own devices. They can modify the code if needed, and they can also use this code as an example to write their own code. And this comes as a package as part of the book.